Okay, in this video, I'm gonna show you how to do eigenvalues and eigenvectors to solve a system of differential equations with a little less work than you initially learned. We're gonna do two systems. This first one is x prime equals -3, 2, -3, 4 times x, where x is a vector. And the second one that we're gonna do a little bit later is x prime equals 3, -1, 5, -3 times x, where x is a vector. I rewrote this one right here for you in like the long form, in the non-matrix form, so that you could recognize it and be like, oh yeah, I've done that type of problem. Ideally, you have solved, ideally you've solved both problem number 1 and problem number 2 already using elimination. If you were going to do them using elimination, you're probably going to start with this. You could solve for y, and then take the derivative, and then plug it into this thing, and then you should know how to use the characteristic equation, all that stuff, right? The reason I have you do that is because I want you to see the parallels between that and this as we go through. So let's jump right into it. What we are going to do with this is I'm going to just call this matrix here matrix A. So A is -3, 2, -3, 4. So there are two steps with lots of details in them that we're going to take to do this. The first thing we're going to do is solve the determinant of A minus lambda I equal to 0. And I'll go into some detail about what that means. And then the next thing that we're going to do is to find a solution to A minus lambda I times A1, A2 equal to the 0 vector. You could write 0 over 0 in terms like the 0 vector could be written like this. Okay, so let me first say what I is. So I take orange. The identity matrix is 1, 0, 0, 1. If I was working with a 3x3 system, it would be ones down the diagonal like this. But that's not what we're doing here, so we'll get rid of that because we don't need it. So if I do lambda times I, then what do I get? I get lambda 0, 0, lambda. So let's do. Okay, so what I'm going to look at first is this right here, and I need a bigger pen. We'll go to there. I'm going to look at A minus lambda I. So this is my matrix A. What I'm going to do, A minus lambda I is equal to, all I do is write the components of A, which are -3, and then the 2, but along the diagonal, which is this piece right here, I'm going to subtract lambda. So I get -3 minus lambda, 2, -3, and then 4 minus lambda. So the next thing that I'm going to do, this equation up here says the determinant of A minus lambda I equals 0. So I'm going to do the determinant of this matrix. Remember, when I do a determinant, we go this way. We do that product minus this product. So when I do that, I get -3 minus lambda. That's the first piece right here. Times 4 minus lambda, that's that plus product, minus 2 times -3. So that actually gives me 2 times -3. You can see I'm going to get a double negative. Now, I want to set that equal to 0 because the first step is to set the det of A minus lambda I equal to 0. Well, this is the det of A minus lambda I, and you can see I've set it equal to 0. So now I just have to do some algebra. When I do that, this gives me -12. This gives me plus 3 lambda. The next one here gives me minus 4 lambda. And then I get a plus because there's a double negative, lambda squared. And then this guy right here gives me plus 6 equal to 0. When I combine like terms, I get lambda squared, and reorder things a little bit, minus lambda minus 6 equals 0. And from here, we simply go ahead and we factor. So we go lambda minus 3 times lambda plus 2 equals 0, which gives me lambda equal 3 comma 2. Sorry, negative 2. One thing I'll point out is that this right here is the characteristic equation for the differential equation, or for this system of differential equations up here. I've said many, many times that anytime we solve a differential equation, we got to go through the characteristic equation, and that shows up in this particular method right there. So what do we do next? Well, so that is, in terms of this step-by-step process that I listed up here, we set the det of a minus lambda I equal to 0. So now, let me just copy this. My next step is to find the solution to this. So I'll come down here, I will paste, and I'm going to do this twice. I've got 2 lambdas, so I need to find the solution twice. So we'll do green. We'll do lambda equal 3 first. So I want to have all my stuff here. So this right here is my a minus lambda I, which is, I'm just rewriting this right here, is equal to minus 3 minus lambda, 2, and then minus 3, and 4 minus lambda. So what am I going to do? I want that times a1, a2 to be equal to the 0 vector. So I'm going to take lambda equal 3 and plug it into this right here. So when I do that, I do negative 3 minus 3, that's minus 6, and then I get a 2. And then I get this minus 3, and then I do 4 minus 3. That gives me 1. And now I need a1, a2 equal 0, 0. I just wrote this out for this particular lambda equal 3. Now, this takes time to get used to. As you get good at this, you just see it. What do I need a1 and a2 to be so that when I multiply across, so that gives me 6, get out of here, negative 6 a1 plus 2a2 equals 0, and then also negative 3a1 plus 1a2 equals 0. So what's called the trivial solution is a1 and a2 equal to 0, but that doesn't help us because it doesn't give us a solution to this differential equation. Instead, what I want you to see is that if I take a1 equal to 1 and a2 equal to 3, then I get a1 equal 1, a2 equal 3. Then I get from this one right here, because it's a system, I get negative 6 times 1 plus 2 times 3. That gives me negative 6 plus 6, which is 0. That also works for this one right here. So what do I get? I get negative 3 times 1 plus 1 times 3 is also equal to 0. So it works, right? So my a1 and my a2 is equal in this one to 1, 3. There's a quick way to do it. You might see it. We can take either one of these. This one is more simple, 3, 1. The ratios are better than 6, 2. And I switch them, right? So instead of 3, 1, I get 1, 3. And then I negate one of them. So in this case, since negative 3 is already negative, if I negate that, it becomes positive. So I get 1, 3. You could do negative 1, negative 3, and that would also work. There's an infinite number of answers to this, but they are all constant multiples of each other. I'll do the short version for lambda equal negative 2 right here, and I'll do it in purple. I'll do it in red. So bigger. Okay, so lambda equal -2. And this is more along the lines of the work that you'll show in general. So instead of all this long work with the green one, when I plug in -2 to this right here, I get -3 and then minus a -2. So that's -3 minus a -2. You see it's double negative. So I get -1 and then a 2. And then the 3 stays. And then when I plug in into this one, I get 4 minus a -2. So again, I wind up adding it. Forgot the negative here, which gives me a 6. When I go across here, I need my A1 and A2. If I take, I would say that this row is more simple than, I would say that that row is more simple than this row. So I'm going to switch the 2 and the -1. So I'll go 2, 1, and then I'll negate one of them. So when I negate the -1, it becomes positive. So my A1, A2 for this one is 2, 1. Notice if I multiply across and down, I get 0 in the top row. And if I multiply across and down, I get 0 in the bottom row. So my eigenvectors are 1, 3, and that goes with the eigenvalue of 3. And then my other eigenvector is 2, 1, and that goes with the eigenvalue of 2. So the final part of this question is to write the solution out. X equals, I take C1 times a vector. I'm going to take 1, 3. And then I'm going to go e to that lambda t times e to the 3t plus C2 times the vector for the second one, which is 2, 1, times e to that lambda value, e to the -2t. And that is the same solution that you should have gotten having done elimination on this same problem up here. And you may say, well, that wasn't any faster. Well, first thing I'll say is that you're not efficient with these yet, and you will become efficient as we do more and more of them. And secondly, I'm going to show you as we move along lots of tricks to skip lots of steps here, and you'll be able to do most of this without writing any work at all. I will do one more video on how to do number 2, and I will do it much quicker than I did number 1. So check the description for that next link to that video.